So, and also please start lining up for questions if you have any.
Might be off.
Screen. Okay. My question is for Gilly. So you showed all these different processing things, and I've dabbled in that a long time ago. Also, it seems to me like it's very hard to do one process to that whole square image to get something good on the inside and the outside. So why not do whatever works best in the disk, then do whatever's best outside the disk by cutting the disk out, and then just stitching the two together to make an image that, you know, is the best of both worlds, instead of trying to figure out all this stuff to get the inside and outside of the same.
It generally can do that. What I like about the RHE method is just that it does it naturally. It just treats every annulus individually and does the same process on it, so you don't have to do any curve fitting to find the limb or really anything. It's regular histogram equalization with the inside here is just treating each radius as the local zone. The adaptive histogram usually does squares across the image and then stitches them together. But you're absolutely right, and I've tried that in a couple different cases. It tends to look a bit unnatural to have the idea like anything like that. Or like even the sunset image that we saw the other day where it's got a region inside, you can tell that it's been treated differently. It was my goal to have a one-shot method that didn't have to take any row tuning except for that which long parameter. And so every image can be treated completely independently. You don't have to build a baseline, and I feel like the on-list version was pretty alright as well.
Because I guess if you're trying to track some kind of wave that's going across the surface and then it's going to the outside, and all you care about is really clearly seeing that in both the disk and the outside. If you have like one of those other methods you're showing where it looks great on the outside, bad on the inside, but great on the inside, on the outside, you want something that's just the both. But
yeah, as long as you're not trying to do anything super quantitative with it, I think that would be fine.
Really, the tools that you were showing, are they available? Could they be exported to ImageJ? Because when I'm looking at, I'm part of the outreach team, and that kind of manipulation, or just frankly playing, could be a terrific way of spreading the word what we're doing with Punch and other instruments.
Yeah, let's talk afterwards if you want to integrate it into some tool. I would love to do that for you.
Wonderful presentations all. Let's see, I want to talk a little bit or comment a little bit on the nature of image processing and what it's for, right? The stuff that Gilly's been doing, you've been doing, Gilly, is really great for bringing things out that you can see by eye. Stuff that Joe's been doing is almost magical. The various other techniques we've seen in the past, and the various radio methods, are important for bringing out different aspects, but we need to make sure that we realize we're interfacing with the visual system, right? So there are lots of things we cannot see, even with enhancement in our own visual system. So if we want systematic surveys, rather than a quick look, we really need to think about how to identify features algorithmically. For example, for cataloging mesoscale features, we really need to come up with algorithms to detect those so we have something reproducible rather than just enhancing and
Like Fourier analysis.
like Fourier analysis, sure. That's all.
So it's mostly for Joe, like if you want to, well, my question to your own work is also interesting. But I was wondering, you were showing your pictures and they look really good. And you're saying, you know, these parts could use some improvement, or we're working on it here. I was just wondering, I was wondering what kinds of qualitative improvements you see being able to make to, or what are the avenues to include more complicated physics or reduce assumptions and things like that.
Right, so, basically, the inversions that I showed have, what in machine learning terms you call a loss function, or regularization, or traditional things, and what I showed there just got an L2 norm, which is easy to implement, has some nice properties. But another thing I've been working on is, a loss function that has, spatial and temporal derivative functions in it. So basically that lets you bake a PDE, for instance, into your regularization for the equation, which can be something simple like a spatial derivative minimization, or you can actually put some physical equations in there, which is a lot more work, but it should be feasible.
Thank you.
Yeah.
So it seems to me, because of the optical thin nature of the corona, so structures that are far away from the plane of the sky are, fuzzy. So the filtering methods, it seems to me they all remove that signal, basically remove the depth of the line of sight. Do we have an estimate for every method, how much we are on the left signal, how much it covers along the line of sight?
I don't currently have any estimates for that, but some of the work that I've done before does indicate that because of the rapidly changing temperature in the corona, you're not always just looking at where you expect in the plane of the sky. Sometimes the foreground and the background definitely do dominate over that because the temperature changes in that island is no longer present in the interior shell.
But do we know how far from the plane of the sky this foreground background is?
I'd say 5 or 6 solar radii is what you should really be simulating if you're trying to get these are spectral lines. If you're trying to get images of that, some people just do plus or minus a half a solar radii. I don't think that that's quite enough, but maybe someone else has thoughts on that as well.
So I would like to only comment about my Craig is not here, but he asked a question about the quantitative comparisons as opposed to the visual stuff. Improvements, what we are developing is 100% quantitative model as problems. So because we measure the orientation angles of the optical features relative to the magnetic field lines. But speaking about the importance of the field of the line of sight collapse of the structures, right? How they show up, again, based on the ground truth validation that we conduct using Cooper's data, the mass model data. What I can tell is that when you trace the features, again, you kind of assume that the features are in the plane of sky, but they aren't, right? They project onto themselves. Because of that, the discrepancy between the magnetic field orientation, the geometry of the magnetic field, and the features in the plane of sky, which we can extract from the model, not from the data, right? They have a discrepancy, say, like 7 degrees plus minus. If you start integrating the model along the line of sight, it rises to like up to 9 degrees. So we actually have an idea, like I'm talking about the angles, right? So we have a quantitative metric to basically tell.
So basically what you're saying, lower down really toward the base of the corona, the assumption being close to the plane of the sky
Yes,
is good enough.
well, within the sectors,
Yes.
so we have an error which increases, but we know by how much.
I've got a, I don't know whether it's a question or a suggestion, but I think a lot of the folks up here who have been dealing with image processing, I think it would be great to get you in touch with working group 1A and Raphael, because I think a lot of the feature tracking and flow tracking activities rely on some kind of pre-processing of the raw images in order to bring out the best details. So maybe there are some new techniques that might help enhance some of those products. Raphael, sure.
Yes, you had exactly the same thought when I was looking at your presentation, and we're already doing these kind of filtering. For the very purpose of PUNCH, of course, we don't need the do anything on the disk. So in that case, we would be more in the very specific case of this coronal, which is purely coronal imagery. We are already doing that, and Craig and his papers have already done a lot about that. I will be happy to experiment. And but if I end up actually having better results, better accuracy out of for the tracking itself, then I'll probably loop you in so that we can integrate that.
All right, any other questions?
If you want to see the near real time images from AIA, processed with my filter, Gilly.space/sun, it's up there, updated every hour, in all of the filters that AIA is delivering continuously. Shameless plug.
Okay. Yes, I guess
We
we
do have
can,
one more question.
oh, sure.
Yeah, so okay, speaking of just the very last comment you just said. So we're actually using these images from their own repository for some sort of space weather forecasting. It uses a time series and imaging as well. So maybe something to consider is to use your images instead and see what difference it makes. So
I would love that.
we top of mind, I think that would be a good exercise to do.
Gilly@surrey.org.
Okay, well, if that's it, let's give our speakers another round of applause.
All right, we're going to take a break now, and it's a poster session. We have an extended poster session until 4 p.m. Then we'll come back here and we'll have